And now, it's time for Gear Jammin' with Bill.
When we're driving cars, trucks, and buses, we're almost always using old-fashioned internal combustion engines. Now, they only have power in a certain range of speeds. That's why we have to shift gears. See, shifting gears can waste fuel, makes pollution, can put wear and tear on you, your vehicle, and the environment. See, if you run an internal combustion engine too slowly, well, it'll stall. If you run it too fast, it'll red line! Electrically variable transmission. The EVT. Planetary gear trains. Energy. Flora, fauna, animals, plants, the environment. It's precious, and we have to take care of it. You see, even though cars, trucks, and buses have been tremendous machines, they've had a big, bad side effect: emissions. Emissions are the gases produced by our cars, trucks, and buses, and just about anything with a fossil fuel-burning engine. These engines spew toxic gases like nitrogen oxide and carbon monoxide that are straining our fragile environment. So if we want a bright future and a clean environment, we have to do better, and we can. Allison Transmission and General Motors have been working hard on a new type of propulsion system for buses and trucks, one that's a lot more environmentally friendly. It gets a lot better fuel economy, and the exhaust is a lot cleaner. We're talking about, ta-da! The Allison Hybrid Electric Vehicle. Now, why would Allison be better at this than anybody else?
This is Allison. What started as a racer's dream soon became an aviation power, leading Uncle Sam to victory. Way to go, boys. Today, Allison Transmission is the worldwide leader in heavy-duty propulsion systems. This division of General Motors is responsible for putting in gear over 80% of the buses and trucks on the road today. Can you say world-class?
Now, you might be saying, what makes this a hybrid vehicle? It looks like the same old bus you see driving down the road every day. Well, wait till you see what makes it go. See, it has an internal combustion engine, but look at all this space. This engine is a lot smaller than it would be on a conventionally powered vehicle.
That's a 5.7-liter inline six-cylinder diesel engine. It's actually the same engine that you'd see in a large pickup truck.
So a pickup truck that weighs like 3 tons,
roughly,
has the same engine that this bus, which weighs 20 tons.
Exactly.
It also has 2 electric motors built right into the transmission.
What you have here is a kind of an integrated package where you've got the electric machines integral with the transmission drive unit.
Now, gas and diesel engines go a long way on a gallon of fuel, and electric motors have a lot of torque at low speed. So a system like this is the best of both worlds. It's a hybrid, a thing of beauty. We want to make buses and trucks cleaner and more efficient. Now, traditional vehicles have a great big internal combustion engine connected to the wheels with a mechanical transmission. Now, here's where things get different. Allison has developed an electronically variable transmission, or EVT. It's invisible magnetic fields driving your bus. It has 2 electric motor generators and a mechanical transmission, all in the same size package as the old ones. Like other transmissions, the electrically variable transmission has planetary gear trains with sun gears, a ring gear, and planet or pinion gears mounted on a carrier. But here's the thing. Unlike regular transmissions, the electrically variable transmission not only has rotating and stationary clutches, it has electric motors. And the electric motors can be used as continuously variable clutches with no rubbing parts. This allows us to draw power and torque from the internal combustion engine or the electric motors continuously, and we call it torque blending. It's an electromechanical thing of beauty. One of the best things about a hybrid drive is that we can use a smaller internal combustion engine because we have the electric motors to help drive the gears. Smaller engines make less exhaust. They're smaller. But on top of that, when the internal combustion engine is incorporated into the hybrid system, we can operate the engine only over its most efficient ranges. And that makes for cleaner emissions. Less hydrocarbons, less nitrogen oxides, carbon monoxide, carbon dioxide, gases that we can and can't see that we don't want floating around in our environment. See, clean exhaust is good for everybody. The electronically variable drive has to store energy. So for that, we have energy storage units. Energy storage units. They're like big battery packs.
The energy storage units.
Now, the energy storage units can only release or receive electricity that goes in one direction at a time. We call that direct current, or DC. And the motor generators can only make use of and produce electricity that alternates with each spin. We call this alternating current, or AC. So we need a way to convert DC to AC and back again. Now, since these devices usually take the bottom part of the signal and turn it upside down, or invert it, they're called inverters. And there's two electric motor generators, so we have two inverters in our dual power inverter module. Dual power inverter module, or DPIN.
So we have an inverter over here.
Here's what an inverter looks like. This is the one we use.
Now, we'd never open this up. We would never open this up.
Ever.
It's full of fancy electrical stuff. But can we see inside this one?
Sure.
Yeah. Oh, so by the way, before you go, see that? Look at that beautiful AC symbol there. Isn't that lovely? And it just makes you think of alternating current. Of course it does. I love it. I got to get one for my truck.
So to get all these components to work together, we need a controller, and we have an electronic control unit. Electronic control unit. Think about it.
This is a computer.
That is a computer.
Imagine something like this in a package that you could put in a truck.
That's right.
Take a beating.
Take a beating, take a licking, and keep on ticking.
But these are the same unit. This is the vehicle controller.
Right.
This is the transmission controller.
That's right.
But the boxes are identical.
They're identical. They're production boxes that we use in our light commercial transmission.
And it works to keep all of the components working together for peak green performance. Whew. Just about anywhere you go, you can find an electric motor at work. When we run electricity through a coil of wire, we get magnetism. It's an electromagnetic thing of beauty. These little cars have electric motors. In the middle is a piece wrapped with coils of wire that can spin. When we run electricity through the coils of wire, the motor spins. And off we go.
Excuse me, Bill?
Huh? Oh. The motors in the EV drive are similar, except these are big electric motors that use alternating current. By controlling the electricity that flows into the coils of the transmission, we can create a rotating magnetic field. The rotating field makes the middle part of the motor spin. Now, on top of that, we can reverse it. By driving the rotor, we can generate electricity in the coils of the stator. It's an electromagnetic thing of beauty. Allison electric drives manage energy. When I push this little car this way, I'm putting energy into a spring. When I let go, we get the energy back. When we push the little car up the big hill, we're putting energy into the car. We give it a nudge, we get the energy back. Are you guys okay?
Yeah, they're okay.
This is an electric generator. When I turn this crank, I'll put energy into this energy storage device, this little capacitor. Ready? Now, when I connect the energy storage device to the electric motor in this little car, we get the energy back. We get the energy back. When you take your foot off the throttle, like when we go down this little hill, the Allison electric variable transmission converts some of the energy of the rolling vehicle into another form, converts it to electricity, and stores it in the battery. So we can get the energy back.
You okay? They're okay.
All kinds of things conduct electricity, like copper, steel, and aluminum. Electricity can even pass through you, and if it does, you can get hurt. The Allison EV Drive has a lot of electrical power, so there's some basic safety rules to always follow.
Tim, what's the first thing in safety? It's know your equipment, right?
That's the most important thing. So the first thing you do is you become aware of your surroundings and you say, is there something that's severely wrong that I shouldn't even be in here on and that I'm not comfortable with? If you're not comfortable with it, if you don't know what you're doing, get out and get somebody who knows what they're doing.
Check with a good voltmeter.
Now I know to go to this box right here that you got these 2 points that you put on your DVM with. And you can read that it's essentially at 1 millivolt or 0.001 volts, so you know that the system is disconnected. The batteries are disconnected from the rest of the system internal to them, so you know it's safe to proceed.
Assume it's hot. All the way to the end.
I'm not going to
Actual
touch this
noogies.
because I don't know what it is, but see that little slot? You can't get them on.
I shouldn't be able to, because you're very aggressive.
Oh, what a satisfying click. Did you hear that? You just make your day, that little click.
Before all of that is turn it off.
Keys
You
in
have
your
key?
pocket.
Let me see the key. See. Okay. Truck's off.
Truck's off.
Ha! There you go. Turn it off, know your equipment, check with a good voltmeter, and assume it's hot anyway. There you are. Done. So this is a battery pack from a truck, and you might think it's electricity. It's dangerous. But let me tell you something. There's about 20 times as much energy in this diesel fuel tank as there is in this great big battery pack. But we're all used to handling diesel fuel. We all know not to start fires around it. So we just got to get used to handling the energy in a battery pack. Don't start electrical shorts around it, okay? Just be careful. It's all energy. Oh, Jeff, it does look pretty simple under there.
It is, Bill. In fact, it can be just as easy as changing your fluids on time and your filters. This is a filter build just like in our WT, so those who are familiar with our WT line of products will be familiar with the electrolyzer. It's pretty simple.
Yeah. Mm-hmm.
Our drive unit also uses fluid to cool it, so we have to check that level occasionally also.
But it's a mechanical thing. So
Yes.
you got to check for leaks,
Yep.
check your fluid levels, change your filters,
Yep.
and then on top of that,
On top
you
of
can run
that,
this diagnostic
we've
thing.
got a diagnostic tool to help us out, Bill.
Let's see, we got fluids, we got filters, we got inspection, just look at it, and then we got the diagnostic thing, right?
That's right. It's pretty simple, isn't it, though?
Very simple, sir. Yes, Jeff. I should get one for my bus. Operating a hybrid bus is just like operating a regular bus. You turn the ignition on, you start the engine, and then it goes through a bunch of self-check features. You hear beeping, and the needles move, and the lights blink. It's really, really fun. And then you want to go. So step on the brake, release the parking brake, and then put it in D for going forward or R for going in reverse. Oh, one more thing. A hybrid has a lot more pep than a regular old vehicle. So you ready? Here we go. You okay? Yeah, he's okay. Well, that's our show. Thanks for watching. If you'll excuse me, I've got some battery plate corrosion rates to assay. See ya! Okay, we're just gonna roll this one. Here we go. If this were on, you know, you'd go like this. You'd go like this, Brian. You'd go like that. So you'd probably only do it once. See what they're trying to do there? See, they're right here. Oh, they're a little there. But they're not here, see? They're trying to make me crazy. That's what it was. So, just let me see if I understand this. We have a video crew with no food and no coffee. I just don't see how that's possible. I've never seen such a thing. I mean, I'm sure it's possible, I just didn't know. I'd never seen a crew run without food and coffee. I never thought of it. I just didn't know that we could have a hybrid drive till a few years ago.